In Chapter 5, we're going to begin our talk of trigonometry and working with a lot of our trig functions. And so we're going to kind of get started here in Section 1 with circles. Now, let's first start with the distance formula, which I'm sure that you've seen before. The distance formula is derived from the Pythagorean theorem, a squared plus b squared equal to c squared. Just solving for one of those, we can see that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so instead of taking each side and squaring it, we're finding the difference between 2 points to get that length. And then instead of having c squared out to the side, we square root at both sides to get there. And so what we need to be able to do is we need to be able to find the distance between 2 points on a graph. And so let's look at this example here. You can see that we have the distance between the points -3, 2. So let's graph this. So -3, 1, 2, 3, 2. There's my point, -3, 2. And then 2, 5. So 2, 1, 2, 3, 4, 5. And I want to find this distance between them here. Now, this isn't a matter of slope that I could count it up or anything. It's a matter of I need to find a distance on a slant there that's not something I could count in units. And so let's notice this. Let's use our formula. And so I have distance equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So then the distance would be equal to, I'm going to plug in those values. I always like to label what I'm working with. Here's x1, y1, and here's x2, y2. And so then x2 is 2 minus -3 squared plus y2, which is 5, minus y1, which is 2 squared. So now it's just a matter of our arithmetic. So this gives me the distance is equal to the square root of 2 minus -3 would give me a positive 5 squared, plus 5 minus 2 would give me 3 squared. Now we're just doing a little arithmetic. So it gives me a square root of 25 plus 9. So we're looking at the square root of 34. But it's just a matter of taking your formula, plugging in your 2 points, and then going from there. So we can see from this that if we went this direction, that would be a leg of 5. If we went this direction, that would be a leg of 3. And then we could see over here that this would be the square root of 34. And so this is really nice being able to use your distance formula, because we're going to get to the point that if you look at things, they're not always going to be a squared plus b squared equal to c squared of I could have just applied Pythagorean theorem, because that just happened to be a right triangle that it created. And so this is going to lead us into a conversation about circles. And so you'll notice here is my circle. I have a center at HK, and I have a point on the circle of XY. The distance between HK and XY is my radius of my circle, and that is the distance between 2 points. So you can see that it's the same formula as before. We've just changed up some of the letters. And so let's make some comments here. So this is the distance between any point on the circle and the center is equal to your R, your radius. And so we can see from this that if we were squaring both sides, the standard equation, you're going to see that word, standard equation would be, so let's look at this. So if I take the square root of x minus h squared plus y minus k squared is equal to r. And if I take that and I square both sides, well, the squared would cancel with the root. So this would leave me with x minus h squared plus y minus k squared equal to r squared. And so what this shows me is this hk right here is the center at h comma k. And so we started with the Pythagorean theorem, we moved it into our distance formula, and now we've gotten to the point that we can apply it to our circles. And so let's take that and let's put this standard equation here, let's put that into the action. So it says, write an equation for a circle centered at the point -3, 2 with a radius of 4. And so let's start with our standard equation that we just wrote down. And so that would be x minus h squared plus y minus k squared equal to r squared. And we want to write an equation for a circle that is centered at -3, 2. So 1, 2, 3, 2. There's -3, 2. And has a radius of 4. So 1, 2, 3, 4. There's my radius. So there's my circle. And so we can see that HK is your center. So this would be your HK values. So that would be x minus -3 squared plus y minus 2 squared equal to our radius of 4, so 4 squared. Cleaning that up, that gives me, that gives me x plus 3 squared plus y minus 2 squared equal to 16. And that would be my equation of the circle. And so you can see there was not a lot of like arithmetic or anything. The main things you would have to know was this standard equation here, and that your center and r, how to take those values and plug them in. Let's take it a step further. Let's do another one. Write an equation for the circle graphed here. So it's already on the graph, so you have to pull your own data. And so you can see here, here's my center. So I have a center at -2, 2. We can see our radius is 1, 2, 3. It's 3 units. So my r is 3. So I would say x minus h squared plus y minus k squared is equal to r squared. And I would plug in those values. So x minus -2, be careful with those negatives, squared, plus y minus 2 squared is equal to 3 squared, leaving me with x plus 2 squared plus y minus 2 squared equal to 9, my equation of a circle. Write the equation of a centered circle at -7, -3 that passes through this point. So with this one, we aren't given the radius, we're given other variables. And so here's HK, here's just another XY value. And so we're actually going to plug in everything we know and see what's left. So again, I'm gonna write my formula. X minus h squared plus y minus k squared equal to r squared. I'm gonna plug in everything that I know. So I know that h is -7. I know k is -3. I know that x is -10. I know that y is -25. I'm going to bring down everything else. Now I had a minus from that formula. And I don't have r squared. So simplifying that up, I get -10 minus -7, which gives you -3 squared, plus -25 minus -3, so it ends up with a -22 squared equal to r squared. So 9 plus 484 equals r squared. So 493 equal to r squared. Solve that for r. Well, we're just going to leave that as r squared because that's the value we want to plug in here. So writing the equation of the circle would leave me with x plus 7 squared plus y plus 3 squared equal to 493. So that one was a little bit different because in our setting up of that equation of a circle, we didn't just have the r, we actually had to plug in a different point, and then we were able to achieve that. And so we did one with the data, we did one with a graph, now we did one with just 2 points. One had to be the center. Next example. Find the standard form for the equation of a circle with a diameter that has endpoints at -3, 10 and 6, 8. So let's pull out what this is saying. Find the standard form for the equation. So this is x minus h squared plus y minus k squared equal to r squared. That's the standard form for the equation of a circle. Now it gave us a diameter with 2 endpoints. Now remember, your diameter is equal to twice the radius. So if I can figure out the length of that, then I'll be able to figure out where what the radius is. Because remember, if you have a circle, the diameter goes through the center in order to get from one side of the circle to the other side of the circle. So to find our R, let's see if we can figure this out. So we're going to have to go back to the very beginning of the lesson and pull our distance. So our distance, or of our diameter, is the square root of, we're going to do x2 minus x1 squared plus y2 minus y1 squared. And I'm just going to kind of label those out here to the side. So negative 3, 10, that's going to be my x1, y1. 6, 8, that's my x2, y2. So I'm going to say the diameter is equal to the square root of x2, which is 6, minus x1, negative 3 squared, plus y2, which is 8, minus 10 squared. I'm going to solve this out. So 6 minus negative 3, that gives me a 9 squared plus negative 2 squared. So it gives me 81 plus 4. So I have the square root of 85 equal to the distance between those 2 points. So that gives me my diameter. So if my diameter is twice the radius, if I divide that by 2, I could say my radius is equal to the square root of 85, square root of 85 over 2. So we have found our R. Now the other piece of information that we need is we need to be able to find our center so we can plug in our HK right here. So what we're going to do is we're going to have to find the midpoint between these 2 points. You can see here that when we're looking at the diameter on our little circle here, diameter has to go through the center. So if I know this point here and this point here, the one right in the middle would be your midpoint. So we're going to have to pull that midpoint out. So I'm going to come over here to the side and work through this. And so now we are going to find our HK, and we're going to do that by finding the midpoint like we just talked about on that sketch. And so to find the midpoint, you just average your x's together, you average your y's together, and that'll find that middle point. So I'm going to plug in just like I did before. So negative 3 plus 6 over 2, that would be my x. And 10 plus 8 over 2, that would be my y. And so that's equal to, let's see, 3 over 2, comma, 18 over 2, so 9. And so now we have our center, and we can write this equation. So this would be x minus 3 halves squared plus y minus 9 squared is equal to our radius squared. So that would be the square root of 85 over 2 squared. We need to simplify that up. You always want to simplify your numbers down to lowest terms. And so then that gives me 85 over 4. The square root would be squared, and then 2 also gets squared. So that would be your final equation. So definitely a little bit more legwork as you're working through a problem like that. But I just want to work through some different examples with you so you can see what's kind of happening as we go on. So I'm going to do one more example. Let's come back over here. Number 6. At what point is the first quadrant does the line with the equation y equals 2x plus 5 intersect the circle with a radius of 3 and a center of 0, 5? So the first thing I want to do is I want to create the equation of a circle. And so in order for me to create the equation of a circle, we're going to have to pull our information here. So I'm going to do the equation of a circle. So that would be x minus h squared plus y minus k squared equal to r squared. Now there's our r, and there's our hk because that's our center, so that would be x minus 0 squared plus y minus 5 squared equal to 3 squared. So it gives me x squared plus y minus 5 squared equal to 9. Just like what we've been doing. Next thing I want to do, so let's see, if we have, let's graph it, 1, 2, 3, 4, 5. And then it has a radius of 3, so 1, 2, 3. If this is our circle, and we want to see where y equals 2x plus 5, so that would look something like this. And we want to know at what point in the first quadrant, remember first quadrant's over here, does a line with the equation intersect the circle? So we're looking for that value there. You can see that if it's intersecting the circle, that's another xy quadrant for us. And so what we're going to do for step 2 is we are going to plug in that 2x plus 5 for y, because we know y is equal to that, and we're going to solve it out from there. So I'm going to take first that equation that I had, and I'm going to plug in this 2x plus 5 right here for y. So that would give me x squared plus 2x plus 5 minus 5 squared equal to 9. So x squared plus, combine that gives me 2x squared equal to 9. Go ahead and square it, that gives you x squared plus 4x squared equal to 9. Combine like terms. And so plugging in that value, we now have it all the way down to a variable x that we can solve for. So divide both sides by 5. That gives you x squared equal to 9 over 5, and then square root. So x is equal to plus or minus the square root of 9 over 5. So that would be x equals plus or minus the square root of 9 is 3 over the square roots of 5, or approximately 1.342. Now they wanted us to find at what point in the first quadrant does the line intersect it. Well, plugging that in, that gave us an x value. If you have an x value and you need to find a corresponding y value, step 3, we are going to plug in to find our y. So I'm going to say y equals 2x plus 5. Now I'm going to use this exact value, not the rounded one, and plug it in here. So this gives me y equal to 2 times 3 over the square roots of 5 plus 5. So it would be 6 over the square roots of 5 plus 5. So approximately 7.683. Now I went back to the original value there because I don't want to take this rounded value, work through all that, and round it again. So the intersection point is at 1.342, 7.683. And you can see that's not something I could have gotten from a graph. That's not something that I could just magically come up with. There was a little bit of work to go with that. So I hope this helps as you start to begin to work on our trig unit here in 5.1, specifically circles. Contact me if you have any questions.